Number 13, we want to determine the following limit. We are given the limit as x goes to 5 of the square root of 3x plus 3 divided by 2x minus 8. And we will first use direct substitution and just see what we get. So we're going to plug in a 5 everywhere we have an x. So that'll be 3 times 5 plus 3 divided by 2 times 5 minus 8. And all of this is under square root. So in the numerator, 3 times 5 is 15 plus 3 gives you 18. On the denominator, 2 times 5 is 10 minus 8 gives you 2. And so you have the square root of 18 divided by 2, the square root of 9, and then we get a positive 3. Because if we got a negative, well, we can say positive or negative 3, but usually just say the positive side of it. So we will say function is continuous, f of 5, when we plug it in, is equal to 3. And usually you would check, if you plugged in a negative 3, the reason why we don't consider the negative 3 is if you plugged in a negative 3, this would come out negative, and this would, and you would not get a real solution. So just 3. All right, number 14, we have a trig problem, and we want to evaluate this limit. Let me pull this down a little bit. Okay. We have the limit as x goes to pi over 2 of the rational expression 5 times cosecant minus 1 over cotangent squared x. Okay, so if you were to plug in pi over 2, it might be better to look at the unit circle. So I'm going to pull up the one from our computer, the trig cheat sheet, and then on the back we have a unit circle. So if you were to plug in pi over 2 into cotangent, okay, let's remind us, what is cotangent? Cotangent is x divided by y. Okay, so when I go to pi over 2, I'm here. X is 0, y is 1. So you will be plugging in a 0 over 1 right here. When you plug in the pi over 2, you would end up with 0 divided by 1. 0 divided by 1 is equal to 0, meaning the denominator would be equal to 0, which does not tell us anything. So we have to try a different method to solve this problem because direct substitution doesn't work. The next thing we do is, since this is squared, we think about using Pythagorean identities. So let me go back up here. So these Pythagorean identities that have cotangent, we're going to use this one. So this one here, it has, zoom in a little bit, see it a little bit better. 1 plus cotangent squared is equal to cosecant squared. So that's the identity we're going to use. I'm going to write that down. 1 plus cotangent squared, and they use theta, but we're using x, is equal to cosecant squared. Okay, so this is the function we want to use. All right, so those are some of the things you got to kind of think about and be aware beforehand. So using this function, it doesn't look exactly like this, but we can get cotangent by itself and see what it equals to by subtracting 1. So we get a different form. We get cotangent squared x is equal to c cosecant squared x minus 1. So this is a different form. So I'm going to replace that here. 5 cosecant x minus 1, I lost my x up here, divided divided by, and we're going to say CSC squared x minus 1. Here we will employ difference of squares, and so we'll factor this, and this will give us CSC minus 1. I keep losing my x, my argument. CSC minus 1, and then cosecant of x plus 1. So these cosecant minus 1 will divide out, leaving us with 5 divided by cosecant x plus 1. And now we're going to try to take the limit of this function now that we have reduced it as x goes to pi over 2. Okay, so cosecant, let me go back and pull that up in case you're not familiar with your trig. Cosecant is, here is 1 divided by the y value. So again, we're looking at pi over 2. So when I go to pi over 2, the y value is 1. And remember, cosecant is just 1 divided by that y value. So it's 1 over 1. So when I plug in pi over 2 here, this is going to give me 5 on the top, and I'll have a 1 divided by 1 when I evaluate pi plus 1. So it's just 1 plus 1. This gives me 5 divided by 2. So we get, our limit is 5 divided by 2. So first we are looking at the reduced form. So we reduced it down to 5 over CSC plus 1. That's D. And then the next part was the limit, which we got 5 divided by 2.